Okay, Algebra 2, Lesson 8.8. Briefly mention this, okay? It's a logistic growth function. Logistic growth functions have one general form, and they are y equals c over 1 plus ae to the negative rx, okay? A, c, and r are all real positive constants. Okay, so we can evaluate it because it's a function, so you can evaluate it just like any other function we have. So if f of x equals 10 over 1 plus 2e to the negative 0.8x, we can find f of negative 2, f of 0.9, and say f of 6. Right, it's just a matter of plugging those in for x. So you get 10 over 1 plus 2e to the negative 0.8 times negative 2. Okay, you can use your calculator because e is the natural base and it's a decimal, and you get 0.917. When x is 0.9, same thing. 10 over 1 plus 2e to the negative 0.8 times 0.9. Order of operations, we put this into a calculator, we get 5.07. And when x is 6, again, same thing, just put in 6 for x, and you get 9.84. Okay, so you evaluate this no differently than you evaluate any other function. You just plug in your value for x and simplify. Okay. Exponential growth functions we saw increase without bound, okay? A logistic growth function, however, has an upper and a lower bound. So it goes from an increasing growth rate to a decreasing rate. Right, so that means is it starts increasing and then it gets to a certain point and it goes to a decreasing function. Kind of looks like a cubic, okay, but it's not quite. So if we look at the graph of a logistic growth function, it has some very distinct properties, okay? It has vertical asymptotes at y equals 0 and y equals c. It has a y-intercept at c over 1 plus a. The domain is all real numbers, because you can put in anything for x, but then your range is restricted to be between your two asymptotes. So 0 is less than y, less than c. And it's increasing from left to right until you get to the point natural log of a over r, c over 2. Then it turns to a decreasing function. Okay, so again, it's between two asymptotes, okay? So it starts increasing, hits the x-intercept at c over 1 plus a. Then it turns to decreasing at natural log of a, c over 2. Natural log of a over r, okay? So it has that general form to it. This is how you're going to graph it. You're going to figure out your asymptotes, the y-intercept, and where it changes from an increasing to a decreasing function, and then they all have this form. Okay? All right. So we're going to graph y equals 3 over 1 plus 5e to the negative 2x. Right? So all we need is to compare it to the parent function here. Not even parent function. The form, okay, to figure out A, R, and C. So A is what the E is being multiplied by. So A is 5. R is what X is multiplied by. So R is just 2 because they're all positive constants, right? And then C is what's in the numerator. So C is 3. Okay, so then you can look at your characteristics. It has asymptotes at y equals 0 and y equals c. Then it has its y-intercept, okay, at c over 1 plus a. So that would be 3 over 1 plus 5, or 1/2. Then its domain is all real numbers, so this is wrong in my notes. I wrote the range as all the domain. So the domain is all real numbers. The range is between 0 and 3. And then that point of max growth, okay, happens at the natural log of a over r and c over 2. So that's going to be the natural log of 5 over 2, 3 over 2. Use your calculator to find the natural log of 5 and divide it by 2. So that's going to be 0.805, 3 over 2. That's all you need to make these graphs, okay? We don't need a table. We just know this general form, okay? So I know it's above the y-axis, or the x-axis, okay? So I'm going to put it here. The asymptotes are 0 and 3. So I know between this line and this line is going to be my entire graph. Okay, because those are my asymptotes. Then the y-intercept is 1/2, so it's going to be right here. Okay? And it keeps growing until you get to this point. So 0.8, right? So almost to 1, and then 1.5. So you know it's going to increase, it's going to cross the axis, increase to this point, and then turn to a decreasing function. And we've made our graph. Okay? And the other thing you can do with this, just like we've done with any other equation, is you can solve it, right? So that means you're going to find x. You're given a value for y and find x. Same way we solved before. Okay? So you want to solve 30 over 1 plus 5e to the negative 2x equals 10. Okay? So I want to get x by itself is in the denominator. So I'm going to multiply both sides by 1 plus 5e to the negative 2x. The first thing I would do, and I did it differently in my notes so you can see both ways, is 10 and 30 can be divided easily. So I'm going to divide out the 10. So I get not 20. I get 3 equals 1 plus 5. Try this again. 10's cancel. 30 divided by 10 is 3. So 3 equals 1 plus 5e to the negative 2x. Okay, then start isolating the x. It's with the base here, so I'm going to subtract 1 from both sides. So 2 equals 5e to the negative 2x. I can't take the log yet because I have this number in front, so I'm going to divide by 5. 2 divided by 5 is 0.4, so 0.4 equals e to the negative 2x. Now, x is in my exponent. There's nothing else but the exponent. So it's base e, which means I need to take the natural log of both sides. So the natural log of 0.4 equals the natural log of e to the negative 2x, right? This is where it cancels. So I get the natural log of 0.4 equals negative 2x. Okay, and then to get x by itself, you want to divide by 2, negative 2. So x is the natural log of 0.4 divided by negative 2. You can use a calculator. And you get x is 0.458. Okay, so our steps are the same no matter what, right? We want to solve just like we've solved in the past. Again, in my notes, I distributed the 10. You're going to get the same thing because eventually you have to undo that distribution, but it was easy to divide 30 by 10 first. Okay, so that's logistic growth functions. Graphing them are probably one of the easier graphs because once you find this information, you plug it in because they all have the same form. It's not going to change depending on anything. Okay, they have this form. It's just a matter of where it crosses the axis and where it switches from an increasing to a decreasing function. Okay, so that is 8.8.